So today's job is to convert this walking stick. Now this walking stick, if you haven't seen these before, have elastic in them, so they all automatically join together. So a couple of the guys I have drinks with of an evening have been talking about a walking stick with a light in it. And so I found this one. I've misappropriated it from my mother, who has several, and I'm going to make a handle with an LED light in it. Now, I did have a torch that would fit in here very nicely, and it's an off-the-shelf solution, but I think I'm going to go a different route with this. So to the breadboard we go, but we're going to have to take the top off this first, I think, and see what sort of space we have to deal with. Alright, so what I've managed to do here is to fold up and tape it up so it doesn't try and latch back into position while I have it on the desk. And sorry about the background noise here. Shortly before filming this video, I fixed my apprentice's mini electronic game. She's decided to enjoy it inside the office. So first thing we need to do is get this little hook off. Now if I seem to fumble with things, that's because I'm having some troubles either with a pinched nerve or with MS. I'm not sure which at this stage until I see the doctors. And the dexterity in good old lefty here is pretty limited. And I haven't done much for the last couple of weeks because of it. I'm now so frustrated beyond belief that I'm not getting anything done that I'm doing stuff anyway. I'm just doing stuff that doesn't matter so much. So now the next question I've got is, how is this thing actually attached? Kind of feels like it's glued or press fit. I'm not sure, so I might see if I can get this whole assembly out and just separate that top section. Alright, so the top section is off and we can see the little gripping assembly here and the locking nut. I'm sorry about the angle here. I still haven't reinvented my tripod yet. So this is the top bit we're dealing with. Now I think if I look down here, let's angle the camera up a bit. The camera might help here with a bit of sunlight filtering in from the side. Come on Lefty, you can do it. We might see what's down there. I don't know, do you guys see a screw down there? I'm looking through the same screen you guys are. I'd hate to have to chop the top off this tube, but let's investigate in more detail, see if I can get this off. Alright, so I took my inspection camera and shoved it down here and discovered that there is a riveted flange underneath this cap, and then it's been glued in. So I'm going to try and heat it up with a gas torch first and see if the glue lets go. If not, I'm just going to sacrifice the top ½ inch or so of that tube there, or even ½ inch, however deep that is. Well, next time people to tell me to get a grip, I'll give them this and tell them I don't know how. Okay, we have the top off, and Mr. Bong Torch can go out of the way, and get my calipers working here. So we need to measure the diameter of this, which I'm hoping shouldn't be a particularly big challenge. It can be in some situations. So that looks like, oh, with a label is a bit thicker. It looks like we're about 22.45, which is going to round up to about 22.5, I reckon. So that's what I'm going to go with. My printer's not terribly accurate, but I have been donated a new printer as well, so that might get a run in the next few days. It is a Bowden's extruder, which is really annoying because I don't like those things. But I'm having troubles direct drive as well, so maybe I just hate loading films with the printers. Alright, let's get all these tools off the desk and let's get on with the design of this. Alright, I have myself some components. I have a bunch of mystery LEDs. These were bought out of China in a bulk pack, and I know nothing about them, what their forward biases or anything like that, or what current rating. So I'm just going to have to eyeball this. So I have myself a twin AAA battery pack, and I have an apprentice who won't stop pushing the same button. And I've got a whole heap of resistors. So I'm basically going to stick a few of these in parallel, I guess, until the current loading is right. I might even string a few in series, and that might tell me what the forward bias is. We might blow a few up. We'll figure out what happens. I'm just going to do this the hard way. So, knowing what these are like when I hook them in 12 volts with a 390 ohm resistor, they're quite bright. So I figure what I'm going to do is I'm going to stick a heap of these on the power rail. And from what do I remember about LEDs, the short leg and the big section in here is usually the cathode, which we power from the negative rail. I'm going to drop a few of these in parallel in the negative rail here in the breadboard. And I think I'm just going to feed it straight out 3 volts and see what happens. I reckon probably 5 or 6 of these is going to happen. I've got heaps of these guys, so it don't really matter what goes on here. So I think, should I feed it 3 volts from my variable supply? Should I put a resistor? You know what, let's start with a resistor. That's going to be the safest option here. Start with our resistor, stick our resistor across the positive, just because we can. Plonk it in over here, and I'll feed it 3 volts from the variable supply. Let's grab my probes. Okay, so I've got my multimeter in here off the side. The LED self-powered voltmeters I've got in my test box won't actually show me anything below about 4.5 volts. So let's just dial this voltage down a little bit from the variable supply till we hit about 3 volts. That's going to be about right. And I'll wind the current limiting down just a little bit. There we go. So our current limit's set to probably about 200 milliamps at the most. Alright, so let's just pull these out and look at our probes in the board. Okay, well I haven't tested this off camera yet like I normally do. So let's just see if we can blow things up. Well, they work. They haven't blown up. But they're kind of dim. They're not really useful for much. So let's see what happens if I dump power straight to them. Here we go. That's a little better. I think we're right on the current limit. They're flickering a little bit. So let's dial our current limit up a little bit. And I'll switch to current limit on the power supply. So let's just fly up to my lab supply, see how much current we're using. So we're up here. We're drawing a little under half an amp at that point. So let's go back down and we will change to directly powering these and see what our current draw is. So we're pulling not much different current wise, but we're getting a much better intensity. I'll leave these run for a little bit and see if they blow up. Well, they are significantly brighter, and they're not looking purple or blue like they tend to when they're about to burn out. So I think actually I can just run these off 3 volts as is. I think most of the cheap Chinese torches, that's all they do. So let's get this battery pack set up and plug it in. Right, so let's throw in some of the cheapest possible AAA batteries I could find in my collection. Useful for testing purposes. And this plastic seems to develop an incredible amount of static cling. I'm not entirely sure why, but if I want to make a Van de Graaff generator, I'll use this stuff. Right, yeah, I'm smart. Got it backwards. Alright, it has an on-off switch, so I'm going to leave the switch in the off position. And you know what, just because it's fancy, I'm going to put the cover back on. With the cable stuck in here. You may or may not be able to hear in the background, I'm not sure which way this microphone's pointing. But those Karawongs are having a field day out there. They followed me around to the other side of the house, I think because they think I'll have food. Alright, I'm just going to directly connect the power, unregulated, no resistor, straight to, I think, 6 LEDs. Well, that's pretty good, and that's significantly bright. I really think it's going to be that simple. Alright, well, you know what? That's all I'm going to do. I'm just going to whack that in there. And let's make a little assembly with that. That's probably the simplest circuit I've done in a while, actually. So, alright, let's get on with the 3D model and the printing. So we're just printing the end caps to start with so that I can be assembling the LEDs whilst the handle prints. And my apprentice here is keeping a close eye on the print job for quality control. And she'll intervene if it starts to slip or has a print problem.
Now press this over use the buttons.
Yep, we can hear the filament slipping, I know.
I know. See, look.
When this is finished, I'm going to start work on a new donation, and hopefully that will finish the job.
It's the belt. Look, it's the belt.
Do you think the belt's slipping?
Yeah.
Ah, yeah, we'll be fixing that. Once the new one's happening, we'll rebuild this bigger and better. Okay, so my test prints have printed, but the quality of my old Prusa i3 is starting to really degrade. Really needs a complete overhaul and rebuild, and I've done that a few times. But being as I have a donated printer here, I think I'm just going to put that other one into service and then completely rebuild this. In the meantime, I've got my buddy over at In-Depth 3D Printers. I've got a bit of credit with him, so I've decided I'm going to get him to print the final product of this. But in the meantime, I can assemble the head on this, and I'll do another test print, see how it works. I might come up with a prototype, and from there we'll use the proper quality print that he's made. But the print is going to take around about 6 hours to do that part, so I'm going to let it run overnight. But in the meantime, we'll get the head assembled, find a suitable switch, and go from there. And the other reason I've done these end caps is if I happen to find the switch hole is the wrong size or these don't line up, I can just alter the end caps without having to reprint the real difficult, challenging print that is the handle. So let's get cracking and put some LEDs in this, and while I'm doing that, the print bed can warm up for the second test part of the 6-hour print. Okay, I've got the LEDs mounted in the head here, and just so that you're aware, I've mounted them such that the cathodes are all in the center here, and you'll see why in a minute when I go to solder them. Well, the print quality continued to degrade, got worse and worse and worse till I eventually killed the print. And I'm pretty sure this little drive cog's to blame for the job. I don't think I've ever changed this in the entire time I've used that i3. So I've pulled out an old project I've been working on little bit by little bit, all laser cut, modified from a bunch of different designs I've had, but more importantly, around on the back here has a spare one of these. And because I'm not using this, it's not fully finished yet, I'm just going to flog it off this and see what we can get out of that. Right, so stuff just got real. And I say stuff because of Google's opinion on profanities. Anyway, I've taken actually the whole stepper motor off, the whole assembly, and I've decided I'm going to temporarily convert it to a Bowden extruder, which is particularly challenging given that good old lefty here is not really working very fast. To give you some perception, this is as fast as I can move it, unlike righty here who can do this really quickly. So yeah, this is going to be fun, but I'm sick to death of that direct drive extruder. It was really great, but it's not working right now and I need to fix it. Right, so I've violently torn the stepper motor from its mountings, and you can see it's been warm in the past. So now we're going to mount that to these bits here. There's another bit here, this black block over here. I'm going to mount them on. We're going to mount this guy in there and a spring, and then we'll have adjustable tension. And if I want to advance or retract it, I can just pull a lever instead of having to pull this whole black block apart. And to give you some comparison here, the old system literally just dropped that pulley in a hole there, and that was it. That was all the tension you've got. So hopefully this other system will give it a little bit more grip and a bit more versatility. And we can see here it's been building up with junk for a long time. So I think it's time we retired that. But let's see how we go. So a whole bunch of things have gone wrong. There's stripped threads in the key thread inside the stepper motor that I need. The nut that I lost that I'm looking for is actually just fallen in there. I've only just noticed. This spring is too short for what I need to do, so I have my box of springs here to find a longer one which may be of a lower tension. Not sure what that's going to do, but I think that'll do away with the need for that extra nut. There's lots of crazy stuff happening. We'll get this figured out. Right, so I've been busy with a screwdriver and a fit of rage. I still have the original filament in here. I'm not ready for that yet. However, I have the stepper motor separated from the direct drive extruder. I'm going to convert it to a Bowden tube with this tube here. Next test is to get the hot end heated up so that I can test which direction I've got my stepper motor on. If it's backwards, I'm going to flip a single pair of these and it should run backwards. So let's go and figure that out. Right, our extruder is warming up, or a hot end at least. Let's see if we can get it actually doing something. Let's have a look over here. And it's winding backwards. Okay. I've got two options. I can either swap this over that side or I can swap two coils. Ideas. I think I'll swap 2 coils. Alright, so I flipped red and blue. And now we are advancing through the extruder at the rate we would expect. Now this is a slightly bigger diameter, so I assume my extrusion ratio is going to be off slightly. So I'll probably knock it back just a little bit. That'll be my extrusion multiplier, and we'll see what happens. Right, we have a successful conversion, and it is pushing filament through, but this spring is a little weak. If I hold this on here, we have a dramatic difference in extrusion, so I think I need to put a stronger spring in. Okay, stronger spring later, and we have good curls forming. That's looking very good. The screw is a bit of a hodgepodge with a nut, but at this point it works, and I can probably even print faster, so we'll see what happens. Well, a bit of aluminium aircraft tape, it's stuck on, it works. It'll get me through this print at least. Alright, now let's actually get printing. Alright, print quality is about 1,000 times better now. I think that was definitely my problem, was extrusion. It does make a funny sound because now the extruder is sitting on top of the frame and we can hear all the extrusion noise, but I'll put a bit of foam padding under that later. I want to let this get a few layers up. Holy crap, that looks better. Oh wow. So much better printing. Alright. Right, so it's back to business now. Now that the print is happening nicely, it's time to get all our LEDs connected up. Now I'm still getting my good mate at in-depth 3D printing to do me a decent print, because I will need several of these, and it's a long print time. But now I'm just concentrating here because Lefty's doing the holding today. Lefty normally does the bending, and Righty does the soldering. But you know what? Now, normally I trim these to length, but I think today I'm not going to worry. I'm just going to put a dob of solder on them. And now, yep, Righty's having some trouble now. Oh, the fun it is having a mess. And I say fun ironically. Right, so we're going to just bend these all down so we can do a ring around the outside. Oh, my improvised tripod fell over. Sorry about that, guys. I think that'll be a good job for the Bowden extruder, is a new camera tripod. I think that'll have to be my next project. Alright. Here we go, we'll have a ring. I've got them all bent down, and now we'll solder them all in place. So let's let the soldering iron warm up and find a better place to put the camera. Okay, let's hope our iron is hot enough here. I'm pretty sure it is. Yep. Oh, and we need some extraction here. Because, you know, lead fumes up the nose are not fun. Let's plug in our extraction fan. Alright, that's better. Now, see if we can get these to join. This is where these spudges are. This is my mate from Mick's iPhone repair, and Mick himself dropped a couple of these off, and they are magic. I don't know where they've been all my life. So, yeah, we'll get all this soldered in. Ooh. This could be a little boring. I might speed this up. Alright, it's test time. Got everything wired up. Prepare to be blinded. Well, that works relatively well, I would say. Okay, and we can see the reason why I wired things the way I did. This makes for a very neat, easy connection there. Okay, so there's only the tiniest little bit of light from a blue LED from my switch panel behind me. And Lefty's having trouble holding this because Lefty doesn't work. So let's turn this on and see what happens. Well, we can see quite well by the looks of this. and all the way around the messy area of my workshop, and my case off, and the oil filter for my Land Rover. And yes, another episode of my messy desk. See the monitor up there? Well, I think that's going to work quite sufficiently well. Alright, so let's turn on our main desk lights, and yeah, let's get back to it. Okay, next 3D printing problem. The extruder is slipping. Yay, the tube came out. Alright, next problem. My filament is stuck. I won't go down and it won't come back up, which means I've got to disassemble the hot end. Really glad I asked for somebody else to print one of these. Okay, so it looks like Windows did updates in the middle of the night. This is about 4 hours after it started printing. I knew I should have copied that to the SD card. So I guess we're going to try it again. 3D printing, guys, it can waste a lot of your time.
So this is my life now, waiting for this. This is the 4th reboot loop. Gonna have to get in and block that update. Alright, 5 reboots later, I'm back in. Now, I'd better block that update, and I think this time we'll try it printing directly from the SD card. Okay, well, I've had a quick look at what I had left, and I noticed this. That means the extruder was likely left on all night because the computer just shut the program down without actually any regard to turning off the heaters. So my extruder might be stuffed. So let's hook up to Repetia host, fix our focus, and we'll see if I've got a screwed printer. Alright, now I tried to connect to my printer and it tells me access to COM port 3 is denied. Well, I'm back on again, but this went over several times. This happened several times after the update. I've had to actually uninstall all the drivers for the USB serial interface to make this work, and then reinstall everything again. So thank you, Windows Update. Even when you fail, you still mess things up. Right, so as usual, none of my videos are just simple. So let's turn the extruder back on. We'll hear my apprentice trashing a keyboard in the background there. This is why I have spares. So I'm just going to turn the extruder on, let it come up to temp, see if I can get anything through, or if the PTFE tube is completely stuffed. Alright, I'm going to risk burning my fingers here, but we have filament coming out. Oh, yes, I did burn my fingers, it stuck to them. Alright, so the plan was to save my entire print to this SD card and put it back in the printer. But after the Windows updates, none of my USB card readers work. Not a single one of them. And even though it claims that that update failed, all my USB stuff's up the wazoo. So I've looked it up, and that is a known bug with the update. So clearly they haven't removed everything. So now I have to come up with some other way to get this onto the SD card. And before you ask, yes, I could load it via USB directly to the printer, but that also doesn't work after the update. Thank you, Windows, for making a nice, reliable product. So this is the final solution that worked. I copied the G-code file over Wi-Fi to my phone, which I'm using to film. I found my USB-C hub and plugged in a card reader, the emergency card reader, out of my wallet, which I know works on my phone, and then copied the G-code file to the SD card, and now I'm plugging that in my printer. Frustrating, but yeah, and after I've done all of that and got it working, I've gone over here to my list and I found that it's corrupted one of the drivers for my USB root hub. So I think that'll be the problem. But anyway, at least I can get the print started and I can fix that out in the next 6 hours it takes for it to screw up another print. Right, here goes. We're starting on SD card print. Right, so Windows can't screw this up now. Alright, so we should see that we'll find the bed should be increasing in temperature at some point. This is going to take a while considering it's about 2 degrees C in this room. Alright, print number like 15 or whatever we're up to now, I've lost count. But yeah, hopefully this goes to plan. I'm going to clean up my desk for the rest of the day.
Okay, so while I've been waiting for that print to happen, everything's happened. Well, I've cleaned up the desk, I've started filming another video, I've got another 3D printer running and fixed, vacuuming going on, my apprentice has taken over my sound system, and yeah, it's all, I don't know, what's the word I'm looking for? Thunderbirds are go. Anyway, we'll be there soon. You might find amusing. There's a distortion in it, and I found out why. I've never printed this tall with this printer before, and the belt is getting stuck underneath here, which is messing the calibration off, but it's almost finished. I'm gonna let it go. Right, so after like 2 full days of trying, I got it to print, but I found as it got up to the top here, the belt started to collide with this. I haven't printed something quite this tall before, and so we now have a distortion across the side here. But we'll let this cool off, we'll get it off the bed, we'll get a prototype happening, and then the new printer that I've been putting together might do the next job for me. Right, so I've got it out of the printer and somewhat cleaned up, and I had to change the wiring here because in between here where the screw holes are, I realized that the wires were going to run straight over the top of this little lump here. So I've clipped that out, put a bridge wire in, and then one down to the switch. So I'm going to get this screwed in on here, and I'm going to assemble this deformation and all just as a proof of concept, and then I'll find a way to print a better one soon. Okay, I've got everything test fitted together, and the base switch can go on here. I'm getting tired and hungry now. It's been a full day I've been working on this one project. In fact, it's been nearly 2 full days. Alright, so I'm just going to go ahead and get this assembled. Alright, we have our prototype, albeit a little bit of a stunted or munted appearance. But the switch on the tail cap does indeed work. And we have lighting from it. And it does light up under the messy area under my desk quite well, as opposed to not having it there at all. Now for the dangerous part. I have here a stick of hot glue and Mr. Bong torch, and I'm going to heat this end up and apply a hot glue directly to it. Then I'm going to pressure fit everything straight on the top here, and hopefully it all fits in nice and firmly. And also being a hot glue, it means I'll have half a chance of getting this off again. When I want to make it permanent, I'll drill a hole, clean through everything, and put a nut and bolt through. Okay, everything's black. Well, what are we doing? Well, I got it working, so I'm testing in the backyard, or the front yard. Now the intended purpose for this is to illuminate steps and whatnot. And it appears to be working quite well down here. So we should be able to have a good look around here and see everything around that we need, including the steps. And I'm just going to try and use this to steady myself as I walk towards the steps, and I can easily see, although the exposure on this camera is not great, I can see the steps quite well. So I think that is going to work just right. And for comparison, so I think that'll be good. Okay, so this is the mostly finished job. And we have our switch in here, and an internal battery pack, and 2 Phillips head screws that can easily be used to remove the end cap. This video will probably end up being linked to Thingiverse as well, and I'll put a copy of the 3D designs or the step files in the description below. But yes, this will become a 2-parter when I find one that is not screwed up, or a printer that will actually print that high without causing distortions. I'll make a part 2, because this one's already probably dragged on quite a bit. But I'll do one last thing and show you how this packs up. Now, because I need two hands for this and my lefty's not working right, I'm going to change angle. So this is how the whole thing goes together. It all folds up and there's a little bit of elastic between each of these. There should be a black plug in this one, but it's pulled up the elastic somewhere else. But that's alright. So what you can do with this, if I pick up the camera here with my left hand and hope it's not too messed up, we can go around here and we can literally drop this whole handful and everything will link together. That works very well, and the shock even turned everything on. So that's a very nicely rapid deployable walking stick with light. So that will be good, and I hope to streamline this design at some time in the future, but this is just preliminary prototype. I have to go and see if my neighbour actually likes the design. If he doesn't, I'll have to come back to the drawing board. But that's this done, and I'm glad to see the end of this project for a bit, because to be honest, my 3D printers are frustrating the living life out of me, and I could have chosen a different word there. But anyway, I hope you guys enjoyed it. Let me know. I don't make any money from my videos or from my 3D printing stuff, so you know, just keep that in mind when you complain about stuff. So anyway, I'll see you all in the next video. So stay happy, I guess. See you next time.